Hello everyone, this is Balaji.K.R signing in for Brain Smart Labs. In our previous class, we saw the working of various loops in Java. The topic of loops is not over yet. As you all know, we have covered 2 parts and 2 more parts are still pending. Let us not waste much time. Let us start with our today's session, More into Loops Part 1. Before we start with our today's topic, let us first see what we did in our previous session. In our previous session, Understanding Loops Part 2, we first saw the structure of a do-while loop in Java. Later in our program loopsdemo4.java, we understood the working of a do-while loop, which is almost similar to our while loop. As a part of our curriculum, we saw the difference between a while loop and a do-while loop, which is the most commonly asked interview question today. We then understood the importance of explicitly added logic balancers in while and do-while loops, as these logic balancers, when added, will prevent a program landing up in an infinite loop. In the program loopsdemo6.java, we understood the structure and working of an enhanced for loop, which was introduced recently in Java version 5 to help a programmer with the iteration of arrays and collections. In the end of our previous session, we gave you a do-it-yourself assignment, that is to add all numbers present in an integer array using an enhanced for loop. Hope you have done the same and got your output. In today's class, let us start seeing one more subdivision in control statements, branching statements in Java.
Jumping and branching statements in Java.
Jumping and branching statements are those statements which will help you transfer the program control from one line of a program to another line present in the same program. In Java, we have 4 keywords that will support branching statements in our day-to-day programs, that is break, continue, return and go to. Let us understand one by one, starting with number 1, the break statement. A break statement helps us to forcefully come out of an innermost loop or a currently executing case in a switch block. As the code block terminates after executing our break statement, the lines below our break statement are skipped in the program permanently. For example, a break statement when used in a loop terminates the same when the program control reaches our break statement. Likewise, a break statement when used in a switch case terminates the entire switch block by skipping all lines of code that are present below. Now with an example, let us see how a break statement will work when introduced in a loop.
Working of a break statement in a loop.
In my computer, go to D drive, workspace and then go inside our basic examples folder. Create a new folder by name 09 branching statements, and here is a place where we store all our programs related to this class. Create a new file by name breakstatementdemo1.java, and in this program, as you can see, we have our usual for loop with a special if condition and a break statement. As we compile and run this program, the program control starts executing the same, starting with our main method present in line number 3. Now, as the program control reaches line number 5, the loop counter I gets created and initialized to a numerical value 0. The loop now proceeds with iteration 1 and slowly it reaches line number 7 where our if condition is present. As the condition here turns out to be false, the program control is now shifted to line number 11, and from there the program control continues executing in our loop body. The program continues its execution in the same way even for iteration 2, as the counter value will be now incremented to numerical value 1. In our iteration number 3, as the value of our counter will be assigned to numerical 2, the below if condition will now turn out to be true, permitting the program control to enter the block. Now our break statement gets executed here, and as defined earlier, the program control will now forcefully eliminate the loop body, skipping the further iterations of our loop, shifting the program control directly to line number 13. Once all these jumping, skipping, shifting of our program control gets completed, all because of one single break statement, rest of the program is now executed in peace till the program control reaches the end of our program. Okay, the break statement when executed breaks the loop to let the program control come out. Got it? Yes! It also works the same for our switch block. And to experience this, let us see one more example on our legendary break statement.
Working of a break statement in switch case.
The program here shows you how a break statement will work inside a switch case. As we compile and run our program, as usual, the program control starts executing from our main method present in line number 3. In line number 5, we have a variable I which is assigned to a numerical value 2. Now this variable will be supplied as an input to our switch block, which indicates case 2 of our switch block will now be executed. As the program control reaches line number 6, the program control will now be shifted to line number 11, where our case 2 of our switch block has begun, and from here on the program control continues its execution till line number 12. The break statement in line number 12 when executed as defined earlier terminates the working of a switch block instantly, which makes our program control shift directly to line number 19, thereafter executing the remaining statements of our program in peace. Dude, I have a doubt. You said the loop or the switch block terminates when our break statements gets executed. That's okay. Now what about lines below our break statement? Will that be executed ever again? Very good question. As this is the most frequently asked question in your interview. What will happen to our lines of code which are present below our break statement? Answer is simple. Lines below break statement in a loop or a switch block are completely neglected by our Java virtual machine, as the program control skips the execution of the lines that are present below inside the code block. Okay, apart from loops and switch cases, where else our break statement can be used? Apart from loops and switch case, let me think. Yeah, in your nested loops. Nested loops ಹಂಗಂದ್ರೇನು ಗುರು? ಓ, ನೆಸ್ಟೆಡ್ ಲೂಪ್ಸ್ ಅಂದ್ರೇನೆ ಗೊತ್ತಿಲ್ವಾ ತಮಗೆ? ಸರಿ ಹೋಯ್ತು. ಟೇಕ್ ಅ ಲುಕ್.
Nested loops in Java.
In a program, if two or more loops are present one inside the other, it forms a nested loop. Here, the second for loop with the counter variable j is known as the inner loop, and the first for loop with the counter variable I is known as the outer loop.
Tricky question.
In the below program, how many times the print statement "my name is Balaji" gets executed? Try finding out the answer by executing the same. Don't forget to look at the answer key at the end of this video to verify your output. For now, let us move on with our next topic, break statement in nested loops.
Break statement in nested loops.
In our program break statement demo3.java, we have two loops one inside the other which can be called the nested loops. As we can see, the outer loop here is a basic for loop, and the inner loop present inside our for loop is a simple while loop. Inside our inner loop, we have a break statement present which will be executed whenever the if clause in line number 13 turns out to be true. And if the above condition is true, it lets the program control reach line number 15. The break statement here will terminate the innermost loop, and the execution of our outer for loop continues unaffected. ಗುರು, 5 ಪೈಸಾ ಕೂಡ ಅರ್ಥ ಆಗ್ತಾ ಇಲ್ಲ. ಎಲ್ಲ ತಲೆ ಮೇಲೋಗ್ತಾ ಇದೆ. ಸ್ವಲ್ಪ ಸರಿಯಾಗಿ ಹೇಳ್ಕೊಡು ಗುರು. ಮುದ್ದಾಗಿ ಆಡ್ತೀಯಲ್ಲೋ ಮುಂಡೆದೆ. ನನಗೆ ಗೊತ್ತು ನಿನಗೆ ಅರ್ಥ ಆಗಿಲ್ಲ ಅಂತ. To understand any program, first we need to analyze the program's output. Now I will show you how to analyze a program's output. ಕರೆಕ್ಟಾಗಿ ಕೇಳಿಸ್ಕೊ.
Analyzing the program output.
In the above program what we just executed, we have two counter values as there are two loops present one inside the other. The program control starts executing our main method, and from here it slowly moves to our first print statement, start of nested loops. The program control, when moved to the first line of our outer loop, the counter variable has declared and initialized to a numerical value 0. Now this initiates the first iteration of our outer loop as our program control enters the loop body, which is present right below. As the program control reaches int j equal to 3, the counter for our next inner loop gets initialized to a numerical value 3. Here in this line, our program is preparing itself for the next consecutive iterations for our inner loop, which is a simple while loop. The while loop over here, which is also known as the inner loop, starts executing for 3 successive iterations as the counter value is set to 3. Once the 3 iterations for our inner loop are complete, the looping condition present in our while loop turns out to be false, leading the program control out of our inner loop to execute the remaining statements present inside our outer loop. As we reach line number 21, that is the end of our outer loop, the program control will now jump to line number 6 for it to again start with the next iteration, that is iteration number 2. The program control will now move as usual as it happened before in our previous iteration. It first declares and initializes the inner loop counter, executing the while loop for the next 3 iterations. In the third iteration of our inner loop, the if condition for the first time will turn out to be true, which will make the program control enter the block for it to execute the break statement present below. The break statement will always break the innermost loop. The break statement will always break the innermost loop, making the program control exit our inner loop, terminating the while loop abruptly in between for it to reach line number 20. As the outer loop completes the second iteration, the program control moves back to line number 6, incrementing the counter to prepare for next cycle, allowing the outer loop to proceed with third iteration. As the program control reaches the second iteration of our inner loop, the value present in counter I will be equal to value present in counter J. For it to reach our break statement the second time, terminating the loop for it to never come back again, terminating the inner loop for it to never come back again. The program control is back to line number 6. The program control is now back to line number 6, incrementing the counter value to numerical 3. The outer for loop terminates at this stage. As the value of I is greater than numerical 3, as the value of counter I is greater than numerical 3. ಒಂದು ಲೂಪು, ಅದರೊಳಗೆ ಇನ್ನೊಂದು ಲೂಪು, ಅದರೊಳಗೆ ಒಂದು ಬ್ರೇಕು. ಸೂಪರ್ ಪ್ರೋಗ್ರಾಮ್. ಈಗ ಅರ್ಥ ಆಯ್ತು ನೋಡಿ ಕರೆಕ್ಟಾಗಿ ನೆಸ್ಟೆಡ್ ಲೂಪ್ಸ್ ಅಂದರೆ ಏನು, ಬ್ರೇಕ್ ಸ್ಟೇಟ್ಮೆಂಟಲ್ಲಿ ಯಾಕೆ ಅಂತ. ಅಲ್ಲ, ಇದಕ್ಕೆ ಹಿಂಗೆ ಹೇಳಿದ್ರೆ ಇನ್ನು ಲೇಬಲ್ ಲೂಪ್ಸ್ ನೋಡಿದ್ರೆ ಇನ್ನೇನು ಹೇಳ್ತೀಯೋ? ಲೇಬಲ್ ಲೂಪ್ಸಾ ಹಂಗಂದ್ರೇನು ಗುರು? ಫಸ್ಟ್ ಯು ಲರ್ನ್ ವಾಟ್ ಈಸ್ ಅ ಲೇಬಲ್ ಬ್ಲಾಕ್, ಆಮೇಲೆ ಲೇಬಲ್ ಲೂಪ್ಸ್ ಎಲ್ಲ.
Labeled blocks in Java.
Labeled blocks in Java are simple code blocks that are enclosed with flower braces and has a name. Please note that the name of the labeled block should always be a valid identifier. For example, below are the two labeled blocks by name Iceman and Batman. Dude, I have a doubt. Why do we have to name our block? Good question. The name used to identify a labeled block is only meant for a programmer's reference. You use any identifier to name or you don't have anything to name. A block remains a block. One thing you have to keep in mind, you can never ever use your break statement inside your labeled block. ಏನು ಆಗಲ್ವಾ? ಹೌದು, ಆಗಲ್ಲ. Take a look at this program. Break statements in Java can only be used inside a loop or a switch case. If at all you use a break statement in a labeled block and then compile using control 1, your compiler will slap you with an error stating break outside a switch or a loop. So my kind advice to you all is, ಸಿಕ್ ಕಡೆ ಬ್ರೇಕ್ ಹಾಕೋಬೇಡಿ. ಅದು ಫ್ರಂಟ್ ಬ್ರೇಕ್ನ ಹುಡುಗಿ ಹಿಂದೆ ಕೂತಿರ್ಬೇಕಾದ್ರೆ. ಆಮೇಲೆ ಕಪಾಳಕ್ಕೆ ಏನಾದರೂ ಏಟ್ ತಿಂದರೆ ನಂಗೆ ಗೊತ್ತಿಲ್ಲಪ್ಪ. ಅರ್ಥವಾಯಿತು ಬಿಡಿ. ನೆಕ್ಸ್ಟ್ ಟಾಪಿಕ್ ಈಸ್ labeled loops.
Labeled loops in Java.
It is completely valid in Java to name our loops using valid identifiers. In our program labeledloopsdemo.java, as you can see, there are two nested for loops, one inside the other. As a programmer, we can name these two loops anything we want. For example, outer and inner. As we press Ctrl 1, the compiler compiles fine with 0 errors. And as we run the code by pressing Ctrl 2, both loops are executed with the following output. Machi, you have used two for loops, one inside the other, okay. But in the output pakrappa, some confusion. Can you please analyze this output for us? Nee kekiradu periso, na solli kudukuradu periso. Ippudu chudu.
Analyze the output for simple labeled loop.
As you can see in our program labeledloopdemo.java, we have two for loops, one inside the other, and hence we have two counters defined. The program control here as usual starts with our main method, and the below print statement, start of nested loops, is executed. As the program control reaches the outer loop, the counter here is initialized to 0, and there starts the first iteration of our outer loop. The program control then starts executing the inner loop for 3 consecutive iterations as seen here. Once the execution of our inner loop is complete, the remaining statements are executed till line number 15. The program control is then moved to line number 6 to proceed with the second iteration of our outer loop. The program continues to execute successive iterations of outer loop and inner loop till 3 iterations of our outer loop are complete. Guru, what is the advantage of labeling our loops? Without a label it will work the same way, right? Allé iradu catch. Have you heard of labeled breaks? Labeled breaks Angandren Guru. Labeled break in Java is a powerful way of breaking a loop. Consider our previous program labeled loop demo.java. To perform a labeled break over here, that is inside our inner loop, just add a break inner clause using a conditional if statement. Compile the program by pressing Ctrl 1 so that you get 0 errors, as the statement what you have just added is completely valid. Run the program by pressing Ctrl 2 and you will get the following output. Wait, I know you haven't understood how we got the following output. To understand this, you must once again analyze the output for break inner.
Analyze the output for break inner.
Break inner output is similar to our regular break statement as it breaks the innermost loop in the following program. The program has 2 counters as there are 2 loops present, one inside the other. The program control initially starts with our main method and slowly proceeds to the first print statement, start of nested loops. The program control now moves to our outer for loop, wherein you can see the counter I gets initialized to 0. As the outer loop begins its first iteration, the statements present inside will get executed line after line. Once the program control reaches the inner for loop, the loop counter j will now get initialized to numerical value 3. The iterations for our inner for loop will begin and the condition for our break inner will be checked at each iteration of our inner loop. The program control skips the if block as the condition here turns out to be false for it to reach the print statement that is present inside our inner for loop. Once the looping condition turns out to be false for our inner loop, the program control executes the remaining statement present in our outer loop till line number 19. As the first iteration of our outer loop comes to an end, the program control is now taken back to line number 6 for it to proceed with the second iteration. In the third iteration of our inner loop, the if condition present inside turns out to be true, and here the program control is permitted to execute our statement break inner, and as per the definition it breaks the loop which is named as inner. The program control as usual will execute the other statements inside our outer loop till it reaches line number 19 for it to end the second iteration. As the second iteration of our outer loop completes, the program control is now shifted to line number 6, followed by the verification of the looping condition, leading the program control to proceed with the next iteration. In the second iteration of our inner loop, the break inner statement is executed for the second time, as the if condition permits the control to execute, leading to the termination of a loop which is named as inner, leading to the termination of the loop which is named as inner. The program control as usual will execute the remaining statements, reaching the end of our outer loop, shifting the program control back to line number 6, failing the looping condition for the outer loop to terminate. Failing the looping condition for the outer loop to terminate. Break inner breaks the loop which is named inner, okay. But what will happen if we use a statement break outer? In our program labeled loops demo.java, if at all we change break inner to break outer, the program will compile fine as we press Ctrl 1. Now, as we run the program by pressing Ctrl 2, the code executes fine with the following output. Guru, we didn't understand the output for this example also. So, gottu allige bande.
Analyze the output for break outer.
The program in break outer is almost similar to our break inner program, but here the break statement breaks both inner loop and outer loop. The program here as usual has two counters, as there are two loops present, one inside the other. The program control initially starts with the main method and slowly it proceeds to our first print statement, start of nested loops. As the program control reaches the outer for loop, the counter variable I gets initialized to numerical value 0. The first iteration of our outer for loop begins by executing all statements present inside line after line. Once the program control reaches our inner for loop, the loop counter j will now be initialized to a numerical value 3. The inner loop iterations will soon begin, and as the condition doesn't match for any of the iterations, the program control skips the code block to execute the remaining statements present in the loop. Once the looping condition of our inner loop turns out to be false, the program control exits the inner loop, executes the remaining statements present outside till it reaches line number 19. The program control is now taken back to line number 6 to proceed with the second iteration of our outer loop, incrementing the counter value of variable I, executing the inner loop once again which is present inside. In the third iteration of our inner loop, the if condition result will turn out to be true, permitting the program control to reach break outer, terminating the outer loop as it is labeled as outer, terminating the outer loop as it is labeled as outer. Now the program control will jump to line number 20, executing the remaining statements present till the end. With this, we all should understand label break is a most powerful way to break any loop, my friend. Label break is a most powerful way to break any loop, my friend. Label breaks are very much similar to your regular break statements, but are more powerful as it can break any layer in your nested loop. The following illustration will show you the comparison between different outputs of the same program that are modified using break inner and break outer.
Output comparison for label loops.
And that completes today's topic on More Into Loops Bhaga 1. In tomorrow's class, we will be seeing continuous statement which is even more complicated to understand than your break statement. So stay tuned. Please don't forget to solve our tricky question on nested loops whose answer will be given to you at the end of this video. Do text us your doubts on WhatsApp if you have any so that we can solve it for you. Remember, you understanding the subject is our topmost priority. Subscribe to this channel to stay updated for our next video release. Till then, this is Balaji.K.R signing out. Until then, you know what to do. Muchkond Kodumadi.